Okay, so hello guys. For this video, we are going to discuss what was presented in the Prefinals module we have. So, if you would inspect the module, that the first part of the module is about the transistor circuits, to which you would say, probably man baka mga natapos naman namo, na-discuss naman namo. But this time, I presented it and I gave it to you kay para may reference ka mo sang overall nga discussion. So, since iba yung mga parts of the discussion last time was not fully introduced and wala man yung iba nakabutang sa libro, so I made a research and compiled all these details in order for you to have a reference, maybe not for the subject lang but for the future references. So I have it here now. So here are some of the important definitions when we will be talking about transistor circuits. So we have voltage control device. So since we will be considering this voltage control devices utilizing the static voltage as the controlling signals, uh, not surprisingly called voltage controlled devices. We also have current control devices. So devices working on the principle of one current controlling another current are known as current controlled devices. So, transistor is a three or more element solid state device that amplifies by controlling the flow of current carriers through its semiconductor material. And gain, which is the term used to describe the amplification capabilities of amplifier, it is basically a ratio of output to input. Probably you are aware of all these terms, and um, what I want to present here are the important historical perspective. So, some of this, medyo nabalaan na naton, but ang iban din yung mga names, gusto sulit kini siya gawa sa aton nga, probably as preparation para sa inyong board exam. So, in the next few years, 2 years to, ano na lang, for preparation. So, we have in 1928, the first patent for transistor principle were registered in Germany by Julius Edgar Lilienfeld. So, 1934, so take note of the names lang, German physicist Dr. Oscar Hale patented the field effect transistor. So, 1947, so take note nga naunang field effect transistor na patent. Jean Bardeen and Walter Brattain succeeded in building the first practical point contact transistor at Bell Labs. So, Jean Bardeen kag Walter Brattain. The term transistor was coined by John R. Pierce. So, in 1958, Jack Kilby, an electronic engineer at Texas Instruments, and Robert Noyce of Fairchild Semiconductor independently invent the IC, or the integrated circuit. So we also have in 1962 the metal oxide semiconductor field effect transistors, or MOSFET, was invented by engineer Stephen Hofstein and Frederick Heyman of RCA's research laboratory in Princeton, New Jersey. So probably if makita ninyo ni in the future ang ini nga mga names yung sulit-sulit kani sila, and they are usually ara lagi ni sila tanan sa mga choices halos ni nga mga names. So make sure lang to be familiar lang with their work, at the same time kung anong ilang nang contribution ang year, kung saan una nila ginhimo ang ina nga contribution in electronics. So some of this na discuss na naton, especially the junction transistors, the basic construction of transistor. So, what I include here nga wala nato na discuss last time was testing transistor with an ohmmeter. So, isa ni sa mga wala nato na discuss last time. So, in order for us to test a transistor, for example, kung working siya or hindi, so the series of tests is based on the diode nature sa aton nga transistor. If all these conditions are met, then at least the diode behavior is functional and the transistor is in good condition. So, kinanglan, ma ma-satisfy ng mga conditions para ma-consider naton nga okay ang aton transistor. So, ang gamito naton is an ohmmeter lang, ang i-test natin is the resistance of your transistor. So dapat resistance. So take note nga kung may ara ka transistor ang mga datasheet lang tawon na nimo and para ma-determine nimo kung di na dang mo nga so based emitter kag collector. So hindi na siya actually amo ni permi ang plus star. So depende kung ano ang ara nakabutang sa datasheet amo na dapat ang lantawan nimo amo na imo reference base collector kag emitter. So for your resistance sa base kag emitter nimo. So PNP dapat high, ang NPN dapat low. So kung balis ka doon mo ang probe mo sa imong ohmmeter, dapat REB mo or resistance of emitter to base should be low para sa PNP, high para sa NPN. So RBC, so base to collector, high para sa PNP, NPN should be low. Kung sulion mo dapat, suli man ang value. Low para sa PNP, NPN should be high. But for your RCE, whether suli-sulion man mo probe, dapat high na siya para sa PNP, kag high man para sa NPN nga transistor. So, take note lang of the table para if ever you will be working in the future sa mga projects niyo with transistors, if ever maka face-to-face kita. So, medyo aware na kita kung paano kita mag-test sa transistors. Okay, so hindi na natin pagbalikan ng iba ng mga characteristics of a transistor. So, probably medyo aware na kita sa mga active regions of the transistor. So, what I want to introduce pagid nga wala natin na-discuss last time. So, is the standard transistor marking or paano ginangalanan ng ato nga transistor. So, this is according to the Joint Electron Device Engineering Council or the JEDIC. So, may ara na siya apat ka component ang naming sa atong transistor. First, we have the digit, we have a letter, we have a serial number, and may suffix siya sa punta. So, the letter is always N. So, and the first letter is 1 less than the number of legs. So, for example, sa aton nga transistor, since may ara kita tatlo ka tail o tatlo ka legs, so 2 na kada per ang iya nga digit tara. So, except for your 4N kag may 5N, kita nga transistor which is reserved para sa mga optocouplers. So, the serial numbers runs from 100 to 999 or 9999 and tell nothing about the transistor, except its approximate time of introduction. So, the optional suffix indicates the gain. So, amo siyang makita naton sa ating mga data sheet. So, diri na ginalantaw kung ano pila ang gain sa imong transistor. So, depende sa sino yung mga value. So, if A ang nakabutang sa punta, that is low gain. If B, that is medium gain. Kung letter C, high gain. Kung wala siya suffix, so ungroup or depende kung ano lang ang gain. So, example sa mga name naton, that is 2N3819, 2N2221A, so 2N904. So, pwede nga may ara ka di suffix sa punta or pwede man nga wala. So, we work sa pila na ka-circuits nga sa previous naton nga mga discussions and we use the value beta. Beta kalabanan ginagamit naton and we also use alpha sa previous nga semester. But kinahanglan naton sila subong i-compare. So for the comparison of your alpha, beta, and also I introduce na lang dari limbutan ko na nga daan kay base ma-encounter ninyo in the future the gamma nga value. So for a typical transistor, a graph of the output versus input is nonlinear. So ang aring mga values derived ni siya sa load line analysis naton. So alpha or the common base amplification factor. So it is the ratio of the collector current change to the change in emitter current, assuming that the collector base voltage is constant. So kabalo naman kita sa value of your alpha. So medyo aware na kita sina. So the typical values dapat sang imong alpha should be 0.9 to 0.9999. Alpha is equals to IC all over IE all over IC, I mean. So for the For the beta naman, medyo amuning permit natin ginagamit. This is the common emitter forward current amplification. So take note of the name. So for your alpha, common base amplification factor. For the beta, common emitter forward current amplification factor. So that is beta is equal to IC all over IB. So medyo aware na kita sinig. Dapat typical values niya is 20 up to 600. So gamma naman niya, common collector forward current amplification factor, so that is equal to IE all over IB. So IE all over IB. So may mga relationship kita nga gina-consider. So but hindi man gid siya masyado ginagamit, but presented here lang sa dalom. So take note of the formulas lang base kinahanglan ninyo in the future ninyo nga mga kinahanglan sumahon. So paano i-derive ang alpha gamit ang beta or ang beta gamit ang alpha. So since amplification ang gina-consider naton nga main gid nga purpose of your transistor aside from switching and aside from iban pa nga purpose. So that's why we study sang transistor amplifier nga configuration. So we have the common emitter. So based sa aton nga na-discuss, so common ang emitter para sa aton nga input and para sa aton nga output. So that is the common collector configuration lends itself to voltage amplification and is most common configuration for transistor amplifier. So ang pinagika-common nga ginagamit ng transistor amplifier is the common emitter. So naka-indicate dere kag naka-table na nga daan kung ano ang mga qualitative nga characteristics kag values para sa aton nga common emitter. So we have the current gain. High dapat ang mga current gain. Voltage gain imo dapat should be high. Power gain is also high. So since taas ang current, taas ang voltage, so power should be high. Input impedance, average 500 to 1,500 ohms. And aton output impedance is also average. So 30 to 50 kilo ohms. So take note lang of that mga characteristics ng aton amplifier configuration nga common emitter. Next, we have the common base. So we know nga common ang base sa aton nga emitter kag sa aton nga collector. This configuration is used para sa high frequency application because the base separates the input and the output, minimizing the oscillations at high frequency. It has the high voltage gain, a relative low input impedance, and high output impedance compared sa aton nga common collector. So characteristic niya, yung current gain, approximately equal lang sa 1 kung common base. Voltage gain, taas siya voltage gain. Power gain, so approximately equal lang sa voltage gain. So input impedance, low yung mga input impedance, taas naman yung mga output impedance. This is for your common base. Next, we have common collector. So the common collector amplifier, often called an emitter follower, since its output is taken from the emitter resistor, is useful as an impedance matching device since its input impedance is much higher than its output impedance. It is also termed circuits with basic gates. So common ang aton nga collector sa both input and output. So yung current gain taas, but voltage gain niya is approximately equal to 1 lang. Power gain is approximately equal sa aton nga current gain. Input impedance naton is taas, so naka-kilo ohm na siya. Output impedance is very low lang. So we have here also transistor configuration nga comparison nga chart. So make sure to familiarize yourself with the comparison sa aton nga mga transistors. So take note nga ang may phase change lang or may phase shift is the common emitter. So voltage gain, so para sa common collector approximately equal to 1. So we have this formulas na ginagamit natin which medyo familiar na kita ginagamit na natin last time. That is equal to RC R prime E. For the current gain, common base approximately equal to 1, and medyo aware na kita sini nga mga formula so para sa nga kinahanglan gamiton for the common collector. So probably may medyo sari-sari lang kita nga mga subscript nga ginagamit or the representation. Sometimes we use impedance, we also present RO sa ibang nga mga formulas. So depende sa mga libro, depende sa ginagamit sa libro. But for as long as you know kung ano na ang purpose niya, ano na siya sa aton nga circuit, so medyo hindi na kita magtalang, depende sa Bisano pa na nga source ang gamito niya, whether Filipino na nga book or international book, medyo mangin-aware lang kita. So power gain, para sa power gain, so low para sa common base, common emitter is very high or high na siya, for common collector medium lang. So para sa impedance natin sa input, so low for the common base, high para sa aton nga common collector, and average lang for the common emitter. So for the output impedance, so mo yung ginagamit natin nga mga formulas. Okay, so for the DC analysis naton nga comparison last time, so basic and discuss naton. So take note lang, ara naman da sa inyo ang tables, it was discussed last time. So I presented here lang sa mga formulas nga pwede makonsider, pwede natin magamit. So we have the following nga table nga naka-indicate dira ang mga formulas na pwede ninyo mangin reference kung mag-solve ka mo sa mga problems. But anyways, kung medyo okay naman ta nga kita ang nag-solve or kita ang nag-obra sa formula, so it's okay lang nga hindi kita magbase sa sini nga mga formulas. So, okay, so medyo na plus star naman ni siya naton and nakuha na ni siya naton last time. So, we have also discussed small signal nga analysis. So, gamit lang naton ang RE model kag ang T model. So, wala natin i-discuss ang hybrid model, but I presented it here kay para medyo, medyo mangin aware man ka mo, makita ninyo ang inang representation. So, amo ni nga aton nga, gin-discuss, we have the R parameter. So, take note lang, alpha AC is equal to IC all over IE, beta AC is equal to IC all over IB. So, dapat may ara kita sini nga mga values, but ang pinagid ka importante there is R prime E na lang. So ang ginagamit nato is R prime E na lang ang values. So H parameters, so medyo hindi na naton siya pag i-detailed nga kinahanglan i-discuss pa. I presented it here kay para mangin aware lang kamo nga may amo nga mga parameters nga pwede naton i-consider. So we have also multi-stage amplifier configuration. So this is kung ang imong output sang imo amplifier nga una gamiton nimo siya as input para sa next nga amplifier. So we have different coupling method nga gina-consider or kung paano sila gina-obdanay. So we have pwede nga diretsuhanay na lang, direct coupling lang, or pwede nga i-connect mo sila gamit ang resistor kag capacitor nga connection, or we have using sang transformer. So you can do a research kung paano na sila gina-plastar. So this is dapat naka-introduce gamit sa circuits ninyo nga discussion. So this is I presented lang sang siningat topic para mangin aware kamo nga may amuni nga type of coupling or kung paano naton gina-obdanay ang duwa ka transistor para duwa ka amplifier transistors kung gamiton natin sila sa circuit. So, pero pwede man nga diretsuhanay lang sila, just like what we have here, the Darlington configuration. So, kung ang ano lang man ang pinaka namin yung mga property is that so the emitter follower has a pair of transistors in Darlington configuration. In this arrangement, the emitter current of one transistor becomes the base current of the second. So the Darlington configuration acts like one transistor with a beta, which is the product of the betas of the two transistors. So that's why nga gitawag siya nga super beta kay syempre ang beta nga daan gina-amplify ng aton nga may amplification na katabo kung beta pa lang. How much more kung i-multiply ang pagid ang beta sa unang transistor kag ang beta sa second nga transistor. So that is beta 1 over beta 2. So amo lang man ang pinaka-importante gid nga property of your Darlington configuration. So automatic kung mag-analyze ka man sa circuit, automatic lang man consider mo lang may ara ka duha ka VBE. So take note na lang na. So if ever encounter ka mo. So another one nga kinahanglan natin i-discuss later on is about op-amp. A special type of low-power amp with almost ideal characteristic is used in instruments and for signal processing. Among many other varied uses, these are known as operational amplifiers or op-amps. This is because this type of amplifier is used in circuits that perform mathematical algorithmic functions or operations on input signals to obtain specific types of output signals. So, hindi ko na ipag-spoil. We have to discuss op-amps. Kay ari man na siya naka-outline sa aton nga discussion. Hopefully, kaway pa ma-discuss natin or malambutan natin para sa pre-finals. If hindi, you will have it in the finals na lang. So, cascode configuration. We have cascade connection as one transistor on top of another. The arrangement is designed to provide high input impedance with low voltage gain to ensure that the input Miller capacitance is at a minimum. So, we will have to present some cascode and cascade connection sa previous nga or sa next naton nga video. So, for the next nga discussion video. So this is it para sa sining review of the discussion about transistors and introduction sa mga na-miss naton nga topics last time. So this is an introduction for the pre-finals discussion. So we will have more discussion. So for the next discussion video, so I'm sorry, nga we will have just a video lecture because medyo naka-work from home kami. And kabay pa, nga we will have enough resources para maka-Zoom naman kita liwat or maka-Google Meet naman kita liwat. But for now, so kabay pa nga still ara Japon ang learnings kag knowledge through this video discussion. This is it for now. Thank you. Stay safe and God bless.